Okay, now we're going to look at domain and range. Okay, so the domain and range are basically all the possible x values and y values for a function. So the domain first, okay, so the domain is all possible values for the input, or the x values as we normally see it. Okay, so we're going to take a look at a basic function here, y equals x. So y equals x, the domain is x is contained in all real numbers. So this notation means x is contained in all real numbers. The brace brackets means it's the set of. Okay. Now there's no restriction on this because when you look at the equation of a line, y equals x, or with our new notation now we can call that f of x equals x. Okay. So for that one, if you went to graph it, well, it's that. There is no value of x that I can't plug in here to get a y value. Okay? So that's the way you'd look at that. Any real number can be used for the input for that. Now, that's when you look at it as f of x equals x. So there's all possible values for that input are all real numbers. Any numbers that are decimal, whole numbers, fractions, any numbers you can think of that aren't imaginary. Okay. Y equals x squared. Well, if you look at this graph, it is just a parabola. Okay. And for this one, f of x equal to x squared, you can square any number. There is no number that you cannot square. So all the input for this are all real numbers again. So this double-lined R means real numbers. Okay. And then if we look at root x, well, now we have a bit of a restriction because we cannot square root negative numbers. Okay, so this graph here is y equals x. This one's y equals x squared. And for root x, well, we'd be looking at this one here. So f of x equal to root x. Well, that looks like this, okay, as we've seen. So for that one, well, x can be any positive number greater than or equal to 0. You cannot square root negative numbers, so the domain for this is all real numbers. This bar here means such that, and this is x is greater than or equal to 0, so which means that they're not negative numbers. So x is greater than or equal to 0, you can square root it. Okay, so those are the inputs for that one. Okay. Now what about 1 over x? Well, 1 over x, what does it look like? So f of x equals 1 over x. Go back to that graph, and it looks like this. Okay. Well, the only value that x can't equal here is 0, because you cannot divide by 0. And you see this graph, you have this vertical asymptote here. Okay, so the curve gets close to it but never touches it. So x cannot equal 0. And that's it. And that's why we have this domain here. X is any real number such that x does not equal 0. Okay, and what about this one? Absolute value of x. Okay, so when we look at absolute value of x, draw that over here. Okay, it's just this v. Okay, so f of x equals absolute value of x, and you can take the absolute value of any number. Okay, so because you can take the absolute value of any number, you go as far out in the x. Either way, there is no restriction on the x, so x is any real number. And that is domain. Now range is all possible values for the output. Okay, so all possible values for the output is the range. So all the y values basically. Go back to the original function, y equals x. So f of x here. If you look at this graph, basically any y value is possible. If you want a y value of 1,000,000, well, then x equals 1,000,000. So it's possible to get that. So based on all the domain that you can sub into this, what are all the outputs? Well, the outputs here are going to be any real number. for x squared, well, almost the same thing, except for when you look at this graph, the y coordinates of this are all positive. Because when you square a number, it's always going to be positive. So there are no negative numbers in the output. So y is any real number such that y is greater than or equal to 0. And root x, well, we've got this graph here for root x. And again, y is all positive real numbers. Okay, there's no negative ones there. And then 1 over x, well, we've got this graph over here for 1 over x. Well, y is any possible real number except for it can't be 0, because you can see it never hits the x-axis here. So y is every real number except 0. And then the absolute value of x, well, we've got this one over here. This graph is the absolute value of x. So y is any positive real number, including 0. Again. Okay, so a couple other examples here. How about the domain and range of this one? Well, y equals x squared plus y squared equals 25. Well, that's a circle. And the circle looks like this, where it goes from -5 to 5 on the y-axis and -5 to 5 on the x. So it's easy to state the domain here. X, so -5 is less than or equal to x, and x is less than or equal to 5. Okay, so when I write it like this, it means x is between these two numbers, from lowest to highest. And same thing for y, for the range. Okay, y is contained in R such that it's between -5 and 5. Okay. What about this example here? -x squared plus 3. Well, that's a parabola that opens down with a maximum of 3. And this would be our domain and range for that. So the domain, all real numbers. You can square all real numbers. Okay, but the range, all the output, is going to be less than 3. Less than or equal to 3. So y is less than or equal to 3 for all the points on this. And that's domain and range.